So hello students, welcome you all to today's video. Today's topic is variance. This is also a very important topic of statistics as well as data science and maths. So let's start today's topic. So in variance we have two types. One is population variance, second one is sample variance. So we will first focus on the population variance. So this is our formula where the formula says sigma square is equal to summation of I is equal to n 1 to n x minus mu whole square by n, where n is the total number of instances, x is equal to the individual number, and mu is the population mean. So this is a generalized formula. Let's understand first what is the population variance. So as you see, I have taken two data sets, dataset A and B. I have four elements in each. So what we will do, we will just calculate the mean of each dataset. So the mean of A is, so here I have just calculating the mean. If you don't know how to calculate a mean or median or mode, you can go to my previous video and watch it. I have discussed it with a nice example. So let's get back to our topic. That is, we are calculating the mean. 8 plus 9 plus 11 plus 12, that is the sum of the elements by the sum the total elements, that is 8 9 11 12. There is 4 elements, so I will write 4. Exactly in the same way I will calculate this mean also, and you if you calculate, you will be able to calculate that the mean is for A dataset the mean is 10, and also for the B dataset the mean is 10. Now the variance is, if you notice in here in the dataset, if you compare each element with 10, you will be able to notice that the each element is very near the our mean. That means 8 10 minus 8 2, 10 minus 9 1, 11 minus 10 1, 12 minus 10 2. That means all elements of our data set is very near to the our mean. Okay, so here our variance is very low. Okay, and for dataset B, you will be able to see that the elements are very far away from our mean. So I can conclude that here the variance is very near, right? And it is very far. As you can see, 10 minus 1 9, 10 minus 2 8, 18 minus 10 8, 19 minus 10 is equal to 9. So here the difference is around 8 9, and here the difference is around 1 and 2. Obviously this is near the mean, and these elements are far from the mean. So from here we can understand that the far is the distance from the mean, the more is the variance. Okay, so let's come to our this formula, and let's understand the formula with this data set also. So for the first data set, I will write here. Okay, so for A data set, I am writing the formula sigma square is equal to, now here I will write each of the element. First 8 minus the mean 10 whole square plus 9 minus mean whole square. So I have written the whole formula. Let me explain it once again for you. So 4 is the total instances number. There is 8 9 11 12. There is 4 data, so 4. And in the upper case I have mentioned you that the summation will be from I is equal to 1 to n, That means here it will be I is equal to 1 to 4. Obviously there are 8 minus 10 whole square plus 9 minus 10 whole square, 11 minus 10 whole square plus 12 minus 10 whole square. So then I will calculate this and the result will be like, so here we have calculated our variance for dataset A is 2.5. Let's calculate our the same for dataset B, and let's just take that what we have calculated, that this is the less variance and this is the uh, much variance. Let's just check that our decision was correct or not. So after calculating the same sigma square for B, we are able to see that the variance of B is much greater than A. So for A it was 2.5 and for B it is 72.5. So variance of B is much greater than variance of A. So our decision was correct. We have proved that by the formula. So this is our main formula for the population variance. Let's come to the sample variance. Sample variance is nothing but, let's say here we have the population variance is where we are calculating the whole thing for the complete population. Like you see, you have 100 samples and you are conducting or you are calculating the variance for the 100 samples, that is population variance. And when you are just randomly taking some 4 sample from the 100 data and you are calculating the variance, that's called sample variance. And then the sample variance formula is different from the population variance. Here there we call the population variance as sigma square, and here we will be calling our sample variance as a square. Now a square is equal to, here I is equal to 1 to small n. Now please watch that there was a big N and here is small n. Then x minus x mod whole square by n minus 1, and here was big N. So why is this? Because we are not taking the whole sample data, we are just taking some samples from them. If there is 100 data, we are just taking 3 data from that. So that's why we are denoting it as small n. So the next question is, why there is n minus 1? It should be small n, right? But there is a explanation about why it is n minus 1. You see, I have taken a very good example. So let's see, here I have 1, 2, 3, 12 pencils, and according to their height I have just arranged them. And after arranging them, I am just calculating the mean of their height, and I have just draw a line of their mean. It's around this region. Now if I am taking a sample of these 3 pencils, okay, these 3 pencils mean is here, and you can see there is a big gap between the whole data's mean and these samples mean. So we can't there what will be concluding, the sample is very bad for the data. So for this misconception, what scientists have concluded, that there will be n minus 1. See, if I have put it here only n, let's say there is only the numerator is 6 and the denominator is 3. Okay, so let's say this is a I'm denoting this as n. Okay, so here the calculation is 2, 6 minus 3, 2. Now for the same thing, I am just putting this value. This is 6 n minus 1, that is 6 minus 3 minus 1, that is 6 by 2 is equal to 3. You can see that just because of this one, our calculation of the calculation of the variance is increased by 1. So for this minus 1, our this mean will increase to around this region. So our target is to put sigma square equivalent to a square, but if we have just put it in, the sigma square will be very greater than a square, which we don't want. So we will follow this, and we want this for our better experiment, for better result. So we will continue with this formula: a square is equal to I is equal to 1 to n x minus x bar whole square by n minus 1, where the x is each sample, each value of the sample, and x bar is the total mean of the data set, okay, the sample you have taken, their square by n minus 1. So here the total instance is 4, there will be 3, because I am not taking the whole data, I am taking just a sample from that. I hope you the concept of variance, population variance and sample variance is very much cleared. Thank you for watching.